Hello guys, welcome to my channel. So in my previous video I explained about how IgG dryer works, and I also said in my previous video that its heater is having a issue. So when I joined this ship, the electrical officer told me out of the two heater, one heater is isolated due to low insulation problem. So company now asking again to do the troubleshooting. So we'll do the troubleshooting again and we'll remove each element and do mega test, and the element which have low insulation will isolate it and connect the other elements back in the system, and will run the system again to bring and to verify the outlet temperature is coming up or not. So let's start the video.
So the first job we do always is isolation. So when I opened the IgG dryer panel, I found group 1 heater breaker switched off and its 3-phase cable going to the heater element is already disconnected. So I switch off the main breaker of IgG dryer panel to do our job. Also I switch off the other group heater breaker as we'll do the insulation test of both the element, as we don't know from which heater the low insulation alarm is coming, and whenever you switch off the breaker, make sure there is no power is present. So I am checking the voltage across each phase at the output of the contactor, and I found that there is no voltage present. So now we can safely work on the heaters. So this is the circuit diagram of IgG dryer. As you can see, it has two set of heater, that is group 1 and group 2, and these heaters are 3-phase, and group 1 heater is 40.6 kilowatt and group 2 heater is 24.4 kilowatt. So first thing we'll do that we'll check the resistance across the faces of group 1 heater and group 2 heater, and as this group 1 heater is 40.6 kilowatt, so the resistance will get as compared to group 2 heater will be less. And this is the heater panel where each cable is connected to heater element, and as you can see visually the condition of group 1 heater 3-phase terminals is not good. So I removed the 3-phase connection of group 1 heater coming from the panel. Check the resistance across each phase to verify that there is no open connection in the heater element. So when I check the resistance across each phase of group 1 heater, so after checking the resistance across each phase of group 1 heater, I found 8.9 ohm across each phase, which is a good resistance when the power is 40.6 kilowatt. That means in group 1 heater there is no open circuit in the element. So similarly we'll check the resistance of group 2, which is having 24.4 kilowatt. So the resistance will be more as compared to group 1 heater. So after checking the resistance of group 2 heater across each phase, I found the resistance is 17.6 ohms, which is a good resistance. That means in group 2 heater also there is no open circuit in the element. Now our next step of the troubleshooting is to remove each cable coming from the heater so that all the elements will be isolated and we can do the mega test of each element. So now I have removed all the cable coming from the heater element. So we are ready to do mega test. So our ground to ground test is confirmed that meter is getting good grounding. Now we'll do mega test of each element. So after doing the mega test of each element, I found that all elements have infinity. That makes me very clear that there is no low insulation in the heater element. So I decided to do the mega test of group 1 heater phases which is connecting to the heaters, and when I checked the L2 terminal of group 1 heater, I found low insulation. Wherever its L1 and L3 phase have infinity. That means the low insulation is coming from L2 terminal of group 1 heater. I also checked the low insulation for group 2 heater 3 phase cable, and I found that all the phases have infinity. That means group 2 heater does not have any low insulation. Only group 1 heater L2 terminal has low insulation. So I decided to remove the L2 cable which has low insulation in group 1 heater, and I will do the mega test of terminal and cable separately. This gives me a clear idea that from where exactly the low insulation is coming. So first I check the L2 cable of group 1 heater, and I found the cable has infinity resistance. That means the cable does not have low insulation, and when I check its terminal, I found the low insulation. That means this terminal is the main culprit which is giving low insulation, and I also show in the beginning of the video that this terminal is burnt, and this is the condition of the terminal which is clearly indicates that low insulation is coming due to this burnt terminal. We also inspected the condition of insulation provided to these elements, and as you can see in the video, it is looking good. So after my troubleshooting, it is clearly indicates that this heater elements giving low insulation due to these burnt terminals. All elements have infinity resistance. So I make things normal and making the heater element connection back. So we connected all the heaters back, and after connection always double check the tightness of the connection as there were too much cables. So sometimes there is the chances of having loose connection. And about this 3-phase cable of group 1 heater, as I don't have same type of high current terminal, so I made some arrangements to connect group 1 heater cables. So I will be using high temperature lugs until I receive same type of connectors having high temperature and amperage. So I connected the 3-phase group 1 heater with high temperature lugs and use insulation tape and heat shrink for proper insulation. So I am doing the mega test again after connecting the group 1 heater 3-phase cable to element, and this time I found infinity across all the 3 phases of group 1 heater. And similarly, once again I am doing the mega test for group 2 heater also to make sure there is no low insulation coming from any of the heaters. And after doing that, I found infinity across all the heaters. After doing the mega test confirming that all the heaters have infinity resistance, I connected the cables to contactor again, and we started the system in manual regeneration as I explained in my previous video to heat the silica of both the chamber one by one. And as you can see, both the heaters are in use. And I manually checked the temperature of the heater, and it is getting hot well enough. And this is the outlet temperature we achieve from chamber, keeping both heater in use. So when we put IG in the dryer, the dew point should show negative reading.
So that's it guys, I hope you understand the troubleshooting part. We able to solve the issue. Now there is no low insulation and both heaters are running and outlet temperature is 120 degree. So if you really like the video, please support my channel, like, share and subscribe.